Moving on to the Adept level, we're going to talk about surface area now. And well, the difference between area and surface area is just this. Typically the surface area, we're talking about a three-dimensional object. So what we're doing is we're looking at all of the faces and we just find the area of each one and then we add them all up together. It's just like finding the perimeter of an object. You find all the lengths of each side and add them all up together. So definition, surface area, it's the total area of all faces meaning flat surfaces, and curved surfaces. So it's the grand total. So in other words, anything that is exposed to the air, anything that you can see. So here we have a box, or the technical name is a rectangular prism. So we've already found the volumes of these things. It's length times width times height. But the surface area actually is a little bit more complicated, because with a box we have 6 surfaces, right? So we have, or 6 faces. We have this face right here, okay? But then we have another face that's exactly the same over here. So there's 2 of them. So let's see. All right. Let's do this face. So that would be length times height, and there are 2 of them. So this would be 2 times length times height. Okay. But then we have face over on this side. But it's also repeated over here. So there's 2 of them. So if that's the height, this is also the height. So plus 2 times the width times the height. Okay. And then I also have this top here, that face there. But there's also one on the bottom that's exactly the same. So that's the length. This is also the length. This is the width. So I just need 2 of them. So it's 2 times length times width. Now it doesn't matter the order in which you write these terms, but this is one way of expressing the surface area of a box or a rectangular prism. Next we have a cylinder. You should be familiar with what that is. And the surface area of that is, well, if you just find the area of this circle, which is just pi r squared, you double that because we also have one on the bottom. So that's going to give me 2 pi r squared. Okay, so this part of the formula is just the 2 circles, the top and the bottom. But we also have to find the surface around here, this curve that goes all the way around. Okay. Now you should have seen where this part comes from in a previous math course, so I'm not going to explain it, but the surface area of this red bit, we also call that the lateral surface area, is 2 pi r h. Okay, so if this cylinder was, let's say, hollow, okay, so we had no top, no bottom, and you just wanted to find the outside surface area, all you'd have to do is eliminate this blue part here, and you just find 2 pi r h, and that would just give you the area of this curved face right here. Next we have a sphere, just a ball. What is the surface area of that? Well, we have a radius. The surface area is given by 4 times pi times the radius squared. That'll give you the surface area of a sphere. Moving on to a cone. All right. Like the cylinder, we have 2 parts. Okay, so the surface area, outside surface area, we'd want to find the area of the bottom, which is just a circle. So the area of a circle is just pi r squared. Okay. But we also need to find the lateral surface area, so that's all the way around here, this curved face. Okay. So notice here in the picture I have the height, straight up and down, and then I have this length here. It's called S. This stands for slant height. All right. And we actually use that as opposed to h when calculating the surface area of this red section here. And that is given by pi times r times s. Okay? So if you, let's say we had a little paper cup in the shape of a cone, it would obviously have no bottom. So if you wanted to calculate just the outside surface area, you would take this formula and you would remove the pi r squared and you just use the part in red. So it's not so important that you memorize all of these formulas. What's important is that you understand what they're saying and what each piece of them actually represents. Finally, I have a square pyramid. A square pyramid just means that the base, this bottom face here, is a square. And it's similar to a cone, at least in terms of how it's labeled. We have a height, okay, so it goes straight from the center right up to the very top. We call this the apex. But then I have, right here down the middle, a slant height. Okay, so really, to find the surface area, we find the area of the square. Well, that's just base times, or b times b, or b squared. Okay. But then I have to find the areas of these four triangular faces. And you should know how to find the area of a triangle. So I'll just highlight one of them. And this is a square pyramid, so all I have to do is find the area of one of these red triangles and then multiply it by 4. Okay. Well, just do it up here. The area of one of these triangles is 1/2 times the base times the height of the triangle. What's on a slant? So the height of this triangle is actually s. Okay. Now, there are 4 of them. Okay. So if you multiply that by 4 on both sides, I'm just showing you why it is the way it is. Well, 4 times 1/2, that's just 2. Okay. So in my formula for the entire surface area of the pyramid, I'm going to get 2 times b times the slant height s. You may think, well, why isn't this a 4, not a 2? Well, there is a 4, but don't forget, in here, for one triangle, it's multiplied by 1/2. So 4 times 1/2, that's where the 2 comes from. And again, if this was a pyramid that was hollow, so there was no bottom, and you wanted to calculate just the outside surface area, you would ignore the b squared, and you just use the part in red. All right, let's solve a couple of problems. The diameter and height of a cylinder are 4 centimeters and 4.5 centimeters respectively. So that just means that I match them in order. Assuming the cylinder has no top, calculate the outside surface area. Okay, so that is a very important piece of information, because if you ignore this, well, simply put, you're going to get the wrong answer. So let's draw a picture. I can draw a cylinder, no problem. There we go. Doesn't have to be perfectly to scale. This is just to help you out along the way. There we go. So what do we know? We know that the diameter, so that is straight across to the other side, that is 4. But I know in the formula it typically is not given in terms of diameter, it's given as radius. So I'm going to use radius instead. So if the diameter is 4, you should know immediately that the radius is 2. So you should be able to freely move back and forth between a radius and a diameter. But we're told that the height is 4.5. Well, that's no problem. 4.5 centimeters. So we want to calculate the surface area of this cylinder. But it's important to remember that there is no top. Okay? So I want to calculate just the area of the bottom and then the lateral surface area, this outside face. Well, oops, let's get blue back here. The surface area of a cylinder, normally, if it's solid, is 2 pi r squared plus 2 pi r h. But again, it's important to understand what this formula is trying to say, because this formula actually is not applied to this situation because there's no top. Well, that affects this part right here. So if we only want to include the bottom, I don't want that 2. Okay? I just want 1 pi r squared. So the surface area I want to calculate is pi times the radius, which is 2.0 centimeters, all squared, plus 2 pi times the radius again, so 2.0 centimeters, times the height, which is 4.5 centimeters. Okay, so I'm going to use my pi button again on my calculator, so I know I'm going to get an approximation. So pi times 2 squared plus 2 times pi times 2 times 4.5, and I get approximately 69.1. And again, this is an area, so my units, can't forget them, centimeters squared. Okay, so just be careful that you include the right components within the formula. Number 2, 2 square pyramids of equal size are pressed together, bottom to bottom, to form a solid. If each pyramid has a base length and slant height of 3.2 centimeters and 4.4 centimeters respectively, calculate the surface area of the solid. Now this may seem difficult, but if you draw a picture, it doesn't have to be perfect, it might make things a little bit more clear to you. So I'm just going to draw the square, but it's in 3D, so it appears kind of as a parallelogram or a rhombus actually. There we go. Okay, so I'm just going to draw a little dashed line. Here's my height. So I'm just going to connect all of these right to the top in a straight line. So this one's hidden, so I make that dashed. Okay, so there's one pyramid, but I have 2 of them. So this actually goes all the way down. Okay, and so I connect that, and that, and that. Whoop. And this one, but that one's hidden, so I'll make that. You don't have to draw that one if you don't want to. Okay, so I have some kind of a funny looking shape, just 2 pyramids stuck together. And I want to calculate the surface area. Well, when you're calculating surface area, you're only meant to calculate the areas of all the faces that you can actually see. So because they're pressed together, both bases, we can effectively ignore them. So we don't have to calculate the areas of the bases at all. So really, we have a pyramid with 4 triangles, but there's 2 of them. So all I have to do is calculate the area of 8 triangles, and then I'm done. So I'm going to look at the surface area of one standard solid square pyramid, and then we're going to adjust it. So remember, it's the base plus 2 times the base times the slant height. So that would give us the surface area of just one pyramid. But we have 2 of them, and they're pressed together. Okay, so we're going to lose this piece, but in effect, I have to double this. Okay, because this 2 times b times s would give me all of these 4. Then I have to double that to get those 4. So this should actually become a 4. This is kind of sloppy math, but just want you to see how it changes. So the surface area that I'm really looking for is given by 4 times the base times the slant height. So it's a pretty simple calculation. So 4 times the base, which is, okay, this is respectively, so that is, well, in this case the order doesn't matter anyway. And that's slant height, yes. Sometimes they give us the actual height, and that gets a little bit more complicated, but we'll get there. So 3.2 times 4.4 times 4, oops, and we get 56.32 centimeters squared. So again, it's not about you trying to memorize a whole bunch of formulas. It's about taking the formula that will be given to you anyway and adjusting it as needed. So make sure you understand what each part is saying.